So strings are an important data structure in computer programming, and Python treats strings a little bit differently than other languages do. Python's a little more flexible. Python's more flexible about a lot of things. But with strings, we treat strings as both a native data type as well as an object. And technically, strings are an object in Python. But we treat them as a native data type, and what I mean by that is we can do things like right? And this will evaluate to true. So we're treating it as if it's a native data type, as if we can use these sort of operators on it, even though string is also technically an object, and we can use string methods on it as well. And we'll see how we do that. So an important thing to know about strings though, so let's take some sort of string and we'll just stick with hello, and maybe there's a space at the end. So remember, it's not just letters, it's also numbers, spaces, any kind of character that you can imagine from the keyboard. Maybe not emojis yet, but letters we can and numbers and characters that we can put inside of a string. And strings are immutable. So this means I can't change any piece of this string without changing the whole string. Why would we care about that? Because we can actually index into a string to return certain letters, but because it's immutable, we can't change those characters, return certain characters, but we can't actually change those characters. But all strings, each character has an index, it's a number, and it starts at 0, 1, 2, 3, 4, 5. And of course, in computer programming, we almost always start with 0 unless we're talking about databases, and then we're going to be difficult and start with 1 instead. But in most computer programming languages, we start with 0. So the first character is 0. So if I did something like this and I said print string 1 sub 2, what is going to print is the letter L. That's actually going to print on the screen. If I did string 1 sub 5, a space is going to print. If I did string 1 sub 0, the H is going to print. So strings, really important data structure. It's an immutable data structure, remember. In Python, we can sometimes treat strings like a native data type, and other times we'll treat strings like an object, and strings can be indexed into. All right, so those are kind of the basics about strings, and now we're going to get into a little bit more detail about these. So let's talk about indexing and slicing. So we've looked at indexing, and we can use these indexes to return slices. So let's take a look at how this works again. So let's get ourselves a string. So we'll call it string 1, and we'll have I have 2 dogs. All right, so here is our string. It has letters, it has numbers, it has special characters, and it has spaces. We index each of these characters to be able to access each of these characters and see something about those. So here's 0. We start at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. All right, so we have 13 characters inside of this string. If I were to say print string 1 sub 5, what is going to print is the letter E. But I can take more than just one specific character at their index by taking a slice of the string using index values. So if instead I were to print string 1 from index 0 to index 3, what do we think is going to print? So let's take a minute to make a prediction, and then let's actually see what's going to happen. So we have two possibilities here, right? We could go and print from 0 to the 3, and then what would print is I space HA, or this could work like range does, where it's only going to go to 2. So let's take a look and see what it actually does. So if I have string 1, and you'll notice that str is purple, we can't use that as a variable name because that is a reserved word. Well, it's actually a built-in function, a casting function for turning things into strings. So I'll call this string 1, and we'll have our string here. I have 2 dogs, period. And now let's print this slice, string 1 from 0 to 3, and let's see what prints. I space H. So we see that it works like range. It is going to stop 1 before the end on this slice. So I space H. So if I were to print string 1 from 4 to 9, we're going to start at 4, VE space 2 space, and that's what's going to print. It's not going to print the 9. So that's how slicing works. You may see if you have something like this, this means from the beginning to the end, so it's going to print the whole string. If I had something like this means from 1 to the end, so from 1 all the way to the end. And if I had something like this means from 0 to 9. So the default, if you leave anything out, is the very first character of the string on the left side of the colon and the very last character of the string on the right side of the colon, only it actually goes one further when there's nothing there and prints the entire string. So this is actually a good way to make a copy of your string. A very useful piece of information about a string is how many characters it contains. So let's say I have this string, Candy. It has 1, 2, 3, 4, 5 characters. So to determine how many characters that has, Python has a built-in function that would allow you to do that. So if I did something like print len, which stands for length, of string 1, it's going to print 5 characters. And now remember, it's going to count all the characters. So if you have spaces in there, if you have punctuation, if you have numbers, it's going to count all of those, and it's going to let you know how many characters you have in your string. So let's take a look at how this works. So let's get rid of this here. So let's say we want to know the length of string 1. We can just send string 1 to the length function and then print that, and it is going to return 14, how many characters it has. So it counts the punctuation, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So every character in this gets counted. So the spaces count, the punctuation counts, the numbers count. The reason why it's important to actually be able to tell how many characters are in a string is because we can use a for loop to process a string. So let's take a look at that next. So we learned in the last section that you can do everything with a while loop, but that for loops are kind of a shortcut notation for a certain type of iteration. Well, one of the things for loops are really good at is iterating through what we call iterable data structures. And these include strings as well as lists, dictionaries, and other data structures. We're only going to look at strings, lists, and dictionaries in this class. But the indexing makes for loops really handy for looping through a string and taking a look at it. So let's say I have string 1 is equal to candy. Can tell I would like to eat some candy right now. So we know 0, 1, 2, 3, 4. Those are the indexes. We know if we ran the length function on string 1, it's going to return the number of characters, 0, 1, 2, 3, 1, 2, 3, 4, 5. 5 total characters from indexes 0 through 4. So let's see how for loops are really good for looping through a string. So I'm going to say for I in range, from 0, the start. And then what's really handy is that when we use the range function, we go to one one less than the endpoint of the end here, right? So if I were to put from 0 to 9, we would stop at 8. In this case, to loop through to where we look at each character each time through, so the first time through the loop I'm looking at the C because I is equal to 0. The second time through the loop I'm looking at the A because we'll add 1, the step will be 1, and then we'll be looking at the A character. I want to stop at the 5, one more than the last value I need to look at, and it just so happens that the length function of that string will return us that. So I can say the length of string 1. And then I could do whatever. Let's say we're going to print string 1 sub I. That means I'm going to print each, first it's going to be 0, 1, 2, 3, 4. So string 1 sub 0 would be C. So this is going to print C, then A, then N, then D, then Y. And let's take a look at how that looks actually when we type it up. So in here, I could have my for loop for I in range, and I don't even need to know how many characters are in this string because I'm just going to say just go to the length of that string, and I'm automatically going to get one more past the last index, which is exactly what I want. So that's why it's pretty handy. Let's see. I don't know why the computer's yelling at me. That's why it's pretty handy to be able to use a for loop to process a string. So now I said I want to print each letter. So I'm going to use indexing that's going to print each letter, and it's going to print I, then space, then H, then A, then V, then E, then and so on and so forth. And because I didn't use my end parameter, it's going to print 1 per line. So let's take a look and see what this looks like. There we go. I have 2 dogs, so it's going to print each letter because I used indexing. Now, if you notice, you expected to get something from your string, and instead you're getting a bunch of numbers. You might accidentally be printing I. I is our counter variable, and it is actually going to take it's going to be a list of numbers from 0 to 1 less than the length of the string, and if we do that, we're actually going to print these indexes. Now, the Python language has some other shortcuts for us, where instead of using range, we can just say for I in string 1. So this is going to take the value of I is actually going to be the value of I, then the space, then the H, then the A. The disadvantage of this is that you don't get the actual index number. So in general, you will find this more useful, but this can be a quick shortcut if you know that all you want is the characters. You don't need to worry about the indexes. Then we can just do print I, and where this I would have printed numbers, if we wanted to print the letters, we have to use indexing. This will print the actual letters. So these 2 loops here do exactly the same thing. So if I run it, here's the first loop, I have 2 dogs. Here's the second loop, I have 2 dogs. So these loops are equivalent. This is sort of the shortcut where we're actually, I is just going to take the value of each character in the string. Here, I is going to take the value of the indexes from 0 to 1 before the length of the string. And in order to actually access the string, you have to use indexing. But the power of this is you may need this I to be the index for other purposes. And we'll see examples of that. So like I said, in general, this is the more useful form. This is kind of a shortcut form. But it's important that you know the difference between how these 2 work. So as I mentioned before, strings in Pythons are objects, and they come with a number of built-in functions that you'll find useful when you use strings. So in the Python documentation, there's a list of different methods that come built in for you to be able to use on string data types. One useful one is find. You can send what you're looking for, where you want to start looking, where you want to end looking, and it's going to return the position of the lowest position where that substring or that character is found within the slice, and it returns -1 if it doesn't find it. So let's take a look and see how that works. So that's a pretty useful one. All right, so let's see, we've got our string, I have 2 dogs. So let's say, and we'll just print what because it's going to return to us the location. So let's say we want to find, so string1 dot find, and I want to find if there's have inside of this, and I want to start at the beginning, and I want to go to the end. By the way, you don't actually have to do this because the default is just from the beginning to the end, but I just want to show you how this works. So closing up this one, within the parentheses. Here we go. So this should return to us the first location where it finds this. So 0, 1, 2. So this should return to us the index of 2, which it does right down here. And so that's how find works. Now, of course, in this case, we could just look at it and we know, that have is at the index of 2. But imagine you have a string that is, 1,000 characters long that you pulled in a file. You have this giant string and you want to know if there's a particular name in there or a particular location. The find function can be pretty useful for that. So let's take a look at some other functions that are useful. The format function is one of those things that are useful. If anyone's interested, I'll do a separate. I'll just do a separate video on how to use the format function. These days, we use GUIs, and so we don't often really need to format our text, but sometimes we do. So it does come in handy. But we also have, some formatting options within the print function as well. So let's see. Dot index is very similar to dot find, but it raises a specific error when it doesn't find the substring instead of returning a -1. So these is functions are really useful. So going back to, when we were learning about and talking about conditionals, I mentioned that besides, our operators greater than equal to, less than equal to, greater than less than, and does not equal, we also had in, is, and then we had these dot is something methods. So now is when we're going to learn about those different methods. So for instance, if I say something like string1 dot is digit, this is going to return true if all of the characters in my string are digits, and false if there is any one character in my string that is not a digit. And there are a number of these different is methods. So we've got isAlnum returns true if they're all alphanumeric. So, it will return false if there's any spaces, false if there's any punctuation. Isalpha returns true if all the characters are alphabetic and it at least has one character. Return dot is ASCII, is decimal, is digit, is identifier, is lower, is numeric, is printable. So there's all of these is methods, and every single one of them returns true or false depending on what it's testing for. So is lower returns true if all the characters are lowercase. Is upper returns true if all the characters are uppercase. So all of these are really useful in conditionals in Boolean expressions, and you will use those quite a bit. Dot join we'll talk more about when we get to lists. Dot lower will actually return a copy of the string with all the characters that can be uppercase or lowercase, which are letters, converted to lowercase. And so we have a dot upper that will then return everything as uppercase. And you can probably already guess what this is really useful for. Let's say I have some sort of user input, enter yes, no for if you want to continue in a loop, for instance. And while UI dot lower, I can take it in case they enter a capital Y here, or a capital N, and we'll say enter yes to continue, comma no to quit. They could enter a capital Y here, and we don't want our program to break just because they've accidentally entered a capital Y. So we're going to go ahead and take that to lowercase before we compare it. So while UI.lower equals the lowercase y, and this is going to handle both uppercase y's and lowercase y's in our loops. So that is a pretty handy function, the dot lower dot upper. We have lstrip and rstrip, which returns all of the white space. So this looks to the left, and if there's any white space on the left, it will remove it. Rstrip on the right, it will remove all the white space on the right. This is really handy when we're dealing with a lot of text and we need to remove white space because we're maybe cleaning some data or preparing some data for processing. Replace is a pretty handy function. rfind means it's going to start from the right. Our index again is going to mean it's going to start from the right. It's going to start searching from the right. Let's see. Split is pretty useful, but we will look at that a little bit more when we get into lists, because join and split are used to turn strings into lists and then back into strings. What else is useful? Starts with can be useful. I'll let you read about that. Strip will remove white space from the right and the left. Swap case is you're just going to make upper characters converted to lowercase and lowercase converted to uppercase. We can return things as title case, which means it's going to capitalize each word in the string. And those are probably the most useful of our string methods. Play with these, see what they can do. I can show you, for example, that's a good example of how we would use lower and upper. Let's say we want to validate some data. So UI input, enter a number. Now if we want to, before we cast this, to actually check, and let's not do a number, let's do an integer. So let's say before we cast it, we actually want to make sure they entered. We can say while UI dot is digit equals false. So if they're not all digits, then it's not going to be something that we can cast as an integer. So then this is a loop that we can trap them in for data validation in terms of, I'm going to check to make sure they've actually given me an integer before I cast it. So once we get out of this loop, I would be safe to then say UI equals the int of UI. Right? So if we ran this, then if I entered this, it's not going to, even if I entered something like this, it's not going to work. It's only going to exit once I've given something that is all digits. So there's another use for one of those built-in functions. So you're going to find a lot of different uses for those built-in functions as we go along, and you go through different examples. So you're going to want to practice with those and get familiar with some of the options that you have, and have a good time. Happy programming.